Hello, friends, and welcome back to the Complete Tech Heads with me, Tom Edwards. This week, I am joined by an incredibly exciting guest who is Rodrgo Liang. Rodrgo is the CEO at SambaNova Systems, a SoftBank-backed full-stack AI startup that creates specialized AI chips and software to sell to enterprises. He's the former head of engineering at Oracle and HP, and holds a master's from Stanford in electrical engineering. So quite the CV. And today we're going to be talking all about AI hardware. So Rodrgo, thanks so much for joining me. How are you doing?
Doing great. Thanks for having me.
Awesome. All right. Well, look, first of all, there's lots and lots of stuff that I want to talk to you about. Firstly, I've given a little bit of a background to you, but I'd love to get just an intro on why you became interested in this space in the first place. What is it about this particular area of technology that really grabbed your attention and made you want to make things happen in this space?
So I've been in enterprise computing for nearly 30 years now, high performance computing. If you think about the space of high performance computing, where people are solving the hardest problems, technical problems when it comes to businesses, large scale applications, science, medicine, some of the hardest problems that we've tackled. The necessary computational requirements, both hardware and software, that allows you to process all of that data, process all of that information to provide solutions, is just tremendous and requires specialized solutions, both hardware and software. And so artificial intelligence just presented itself yet as another really, really hard problem. And so over the course of my career, having started building large scale supercomputers back at Hewlett Packard with these Superdome systems that even today they still ship. Throughout my career, building high performance chips and systems and software that allows you to deploy web scale, large scale solutions across thousands and thousands of nodes, to now what we are seeing, which is another wave of computational requirements that AI presents, where you're building these incredibly large models. Look at a GPT-4 model from OpenAI and kind of how big that model is, and how many chips and how many systems and how much memory and how much networking, all of the things that are required to power ultimately something that everyone in the world loves to use, which is an AI model that allows you to broadly interact with. And so it's an exciting problem. It's something that the world needs, and we need to be much more efficient at it. We need to be much more effective at it, and we need to also need to bring the cost of deployment significantly down. And some of the things that we're doing at SambaNova is enabling that.
Awesome. Yeah, I want to get on to efficiency shortly, but first of all, if we could just frame this conversation around the chips that we're actually talking about here. So could you kind of give me a beginner's guide to CPUs and GPUs, how GPUs are a development on CPUs, and why they seem to be so important to AI? And then later we're going to come on to talk about other developments that you yourself have been working on those. But first of all, could we just frame the conversation on where we're at now with GPUs and why they're so crucial?
Yeah, and this is for your audience, this is a bit of a just a reminder of kind of where we've been as a tech industry. You think about 10, 15, 20 years ago, and dating back as far as 30, 35, 40 years ago, is the CPU was dominant in kind of what we used as the common unit for computation, right? And back the days of digital and DEC Alpha to what we were building at Hewlett Packard with PA RISC, and of course you have IBM with Power, and you have Sun with Spark, and then eventually Intel came in to dominate the CPU world with x86, and AMD also coming in and playing there. So if you look at kind of for decades, the computational unit that most people would write software on was tied to a instruction set. And the instruction set that, most for the better part of the last several decades was an x86-based architecture led by Intel, right? And, I remember 10, 15 years ago, basically everything ran on Intel, right? And so, and then out of the last, say, 5, 6 years, came this new model that was ultimately around these very large neural nets, of which the computational requirements required a certain type of operation that mimicked a lot of the things that these graphic processors actually had, right? And as you know, with NVIDIA's GPUs, and they had decades focusing on graphics, and there are other companies in the past that did graphics as well, ATI and the 3D effects. Over the history, many companies that did very specialized hardware that allowed you to actually run those specific functions really, really well, which were less suitable to run on a general CPU processor. That graphic operation, with these vector operations, mimic a lot of the requirements that some types of neural nets required.
And so what is it about them then? What's the similarity there between graphics processing and neural nets? I understand it may be super, super technical, that, we could be here for hours, but is there a sort of basic way to explain what that similarity is?
Well, it really started with vector operations as a first start. If you think about kind of how we actually have to manage these operators for neural nets, there are a bunch of things that we got to do as part of a single instruction. And so if you actually take those and you operate it on a CPU, they turn into many, many individual instructions when a single vector instruction will actually suffice. And so it's not like machine learning and artificial intelligence hasn't been around for a long, long time, right? That it has been a long, long time, but the capabilities of the infrastructure, both hardware and software, just weren't put together in a way that you can make effective use of it. So over the last few years, what you see now is the innovations around machine learning and the algorithms, and then the progression of the hardware in order to allow us to actually create these models to be of a certain size and the operation of it to be of a certain speed, have now created a practical use case where these large neural nets can produce what you've now seen over the last few years, the results of a generative AI type of model, right? And so that's a convergence of machine learning and AI that's been around for decades, with the evolution of hardware infrastructure for computational reasons that allow us now to be able to actually create these solutions that are transformative, and we see it every day.
Yeah, so I guess the advent of these incredibly impressive models that we now have, that we all use every day, most of us in white collar jobs using them every day now. It's really a confluence of different things. It sounds like there's the hardware and the software, or not even software, I suppose, but the weights, the probability weights, the way that these models are created. It's a confluence of all of these different things evolving in parallel and then all kind of coming to fruition at the same time.
I would say it's three main things. I would say it's three main things that have enabled what you're seeing today. And we can argue about what those are the only three, but three main things. One, the computational horsepower that we've now been able to deploy with GPUs and other accelerated type of computing infrastructure. And so the computational horsepower has now been able to arrive at a point where you can actually do this type of computation really efficiently, right? The innovations around neural net and being able to create transformer-based models, and now you're kind of getting into these multimodal models, that innovations around machine learning are actually getting the type of complex results that we're getting out of these neural nets. And then frankly, the ability to actually have a large enough data set. I mean, you couldn't have done this if the world of internet had not opened up the data sets into the world. So you really needed a lot of data and be able to crawl that data in order to actually train these models to a level of accuracy that we just couldn't do, nobody could do by themselves with their own small data sets. And so you need all three of those things that the large amount of data existing in the public domain with the computational horsepower, with these neural nets, have now allowed us to create these models, which then now we can use as a base model to apply to a broad range of things.
Interesting. And so this explosion in chip making, NVIDIA has had so many headlines. The stock price has gone through the roof. It's been everywhere. Is there an element of froth and hype there? Or do you think really the opportunity actually is that huge with AI? Do you think that this technology really is going to impact on every single facet of the way we do business?
Well, 100%. If I think about kind of where we are today, and all the excitement there is with AI, and with NVIDIA's success, and they've done a tremendous job capitalizing on it, and you see all these other companies being valued at tens of billions of dollars after only a few years, and then you go and talk to the Fortune 500, the Global 2000, and this is a question I always ask. And I ask, what percent of your daily workflow is powered by the internet? They'll say 100%. Everything they do, right, is centered around internet, being internet powered. What percent of your workflow is AI powered? Less than 5%, maybe 2%. And so if your average company is in 2%, right, on a technology that we expect to have at least the same, if not bigger, impact on the internet, and you know that every company is powered at 100% on the internet, all of this, energy, hype, valuation, all the things that we talk about with AI today, is still early days, because as you know, right, enterprises, the enterprise market is powers industries, right? It powers global economies, and so if those companies have yet to really start, right? They've started kicking the tires, trying different things. Most people have tried some things on OpenAI, kicked the tires, and done some experiments. But what percent of your daily business mission critical workflow actually runs on AI? Low single digit percent. Yeah. Right. And the expectation here is going to be at least as pervasive, if not more, than the internet. And that's the amount of gap that we have yet to go as the technology matures.
Yeah. Yeah. So on that, then, I mean, I for what it's worth, I think you're right. I think I can see it. I can see AI technology being involved in pretty much everything I do on a day-to-day basis. So your idea, or it seems to me like SambaNova's idea on this, is that enterprises should be investing in AI from all the way across the stack. So I've been building, on the GPT-4 API. Colleagues of mine have. Lots of people I know in different businesses are building products on the OpenAI's API. So for anyone who doesn't know what that means, it's just a way of using somebody else's large language model via application programming interface. I don't think that's what you are. So from reading your website, what you're essentially saying is that enterprises should be investing in building their own AIs from the ground up. Is that right?
Well, our view of it is that AI is going to stratify. There will be a bunch of use cases where you can use public models. Yeah. Right? Think of search. There are a lot of our business where you can just go out into the public internet and use that tool as a way to actually answer the questions that your business needs, right? We can go to Google Search, you can go to Bing, and that's kind of how you operate the business. And every single company has a private stack on their private data that they use as intelligence and intellectual property and trade secrets and company IP that they do not want to put out into the public domain, and they do not operate their business through the public domain, right? And so the business is going to stratify in that you don't want AI only applying to public knowledge, right? That you actually have a significant amount of your business that's tied to your company trade secrets, your IP, your regulated data, your customer information, your employee information, all of that you do not want to disclose into the public domain, that also needs to be accessible through AI platforms, right? And so what SambaNova's view of it is that the business will stratify into different use cases, different deployment models, and different, just like an internet does. You don't, it's not like every company only has one internet vendor. Oh, that's not true, right? We use Google, we use Zoom, we use Amazon for buying things, we use Netflix for watching things, right? The industry will stratify into different use cases, but there is a significant portion of enterprise which has private data, highly regulated data, trade secrets, IP, things that you do not want to put in the open domain. And you need to have a secure way of actually including that data and that information into AI systems that allow you to actually compete better, right? Because end of the day, we do fundamentally believe that AI will be a competitive weapon that people are going to deploy. And that weapon isn't going to be everybody has the same model they're operating against. And many of our clients are using these AI models to create a competitive advantage. And by using their own data, their own understanding of their customer, their own understanding of the market, their own understanding of their technology, and tying those together and creating velocity in deploying services to that market, they're using that as a competitive advantage. And they do not want to release that model to share with the rest of the world, right? They see that as their own asset, as something that they uniquely have to allow them to compete better for the next 10, 15, 20 years.
Yeah, and I think you are right. It does seem like, we're even starting to see now there's like copyright issues. People are talking about suing, Stable Diffusion for I think it's Getty Images, all of the images that they've been trained on. The free and open internet being used to train models is going to become an issue, I think, and is already becoming an issue. And so certainly I can see where you're coming from in terms of having something that is entirely owned within a business and not publicly accessible and isn't being sent through API calls to OpenAI. I can see how, lawyers in enterprise firms might feel reassured by that prospect. My not concern, but my assumption would be that to build a powerful enough AI in-house, you would need to be hiring super smart people, people like you, right? Frankly, from, Stanford PhDs, MIT, whatever, in order to build a sufficiently high quality LLM. Now, obviously, most enterprises don't have access to that kind of talent, right? The Silicon Valley behemoths, the Googles and the Teslas of the world and the Nvidias of the world are hoovering them up before they can disperse into the economy at large. So is that not an issue? Like, are you finding that the clients that you're talking to, actually they can access the talent to build these kinds of models? Or do you think that implementation is going to become more accessible over time?
Well, you're spot on this. And this is where our market has grown significantly. If you think about AI, artificial intelligence at the most sophisticated level for enterprises will not be a technology only for the Fortune 10. It will not be, or the Fortune 20, right? And certainly it will not be a technology that the larger companies have a disproportionate advantage over kind of the next tier, like the Fortune 200 or 500. That it's not going to be one where you say, if I'm a Fortune 10, I can produce things and products and services that the Fortune 500 can't. It's too big of a technology transition. And you're spot on this. So what are the limiters, right? What are the limiters to building these things? And some people can say, well, it's so expensive. Actually, if you look at some of these corporations, they have the money. They actually have the money to invest in. Some of the most forward-looking ones, they're actually investing infrastructure to actually build these systems, right? And SambaNova, we, of course, a lot of people view our technology as a way to actually significantly reduce that cost. And so we are able to do that. But that's not the reason why they actually haven't done it. The reason they haven't done it is exactly what you're saying, is you need today to buy bare metal and train it yourself. You need hundreds of machine learning experts that are really, really hard to find. Right? There are PhDs at Stanford and MIT and all these different places. They're, like you said, will choose to go to a Google or an Apple or some of these places that have large AI houses, and yet every business in the Global 2000 needs a set of people. And so with SambaNova, what we did here to solve that bottleneck was significantly collapse the the technical requirements to engage, that allows us to actually have these pre-trained models leaning on the open source innovations that we qualify for our customers so that we elevate the quality of the result. And you can actually get going with state-of-the-art technology with a fraction of the expertise that otherwise you would do if you're trying to do it by yourself.
Interesting. So you're using open source to power it from like, so you're kind of, are you using open source models to feed in so that the enterprise customers don't have to build everything from scratch? Is that the idea?
That's right. I mean, we think that it's a Linux moment for AI, right? We really do, and we've seen this picture happen before. You know, with open source community getting momentum. Once the open source community is innovating, you have a lot of really great things happening, and the power of the world innovating is really hard to stop, right? Versus a single vendor doing it by themselves. And so what we decided SambaNova is to leverage the open source community. But what's hard about the open source community is sometimes the solutions are disparate, right? They're not coordinated because, you know, you have things that are done for this but not thought about for that. And so what most of our clients want is they want a curated version of it. They want somebody that's actually taken what's out there, taken the best and sorted it for kind of what's most useful for enterprises, and then tested it against a common infrastructure that then they can actually lean into. And we've seen this in the past too, right? You saw Linux with Red Hat and other players come in and creating a more robustified solution that enterprises can rely on and be able to then build their business around. And so what SambaNova is doing is, yes, we have the hardware. We can give you this compression and performance and cost advantage by running these large models really, really efficiently. But one of the biggest values is that SambaNova comes with a curated way of actually looking at these open source models that we lean into, and then we're able to quickly bring them to our customers and actually deploy on the hardware so that all the tuning, all the effort that you might have to do by yourself, SambaNova has already taken care of it for you, right? That these open source models are able to come onto the platform. You don't have to go chase around for GPUs. You don't have to go and learn CUDA and figure out how to actually program this thing. You don't have to figure out how to actually scale this thing to hundreds of sockets. You don't have to figure out how to make sure the accuracy is correct. You don't have to figure out how to ingest the data. All the things that you have to hire hundreds of people for, the platform just takes care of you. All you need is present your data to it, and you can present it fully in your own private, secure environment because we bring these systems to you all preloaded with these models already pre-optimized.
Interesting. I mean, it sounds you're selling it well, but yeah, it sounds great. So, and look, I totally agree with you on the open source question. I had a VC called Joseph Jacks on the show, who invests only in commercial open source, and he was telling me about the open source. He actually calls it open weights, not open source. He says there's no source code, it's just weights, so we should call it open weights. I sort of move between, but he was very excited about the open weights community and really doesn't believe that it's actually very far behind the frontier models. He thinks that actually because you have this bigger community, it's actually a more interesting and dynamic space. Do you think the open source community is very close to the frontier of AI? I mean, I presume you must do. You must have a lot of faith in open source in general to be building it into your kind of business model, right?
Yeah, well, I think what you're going to see is that the open source community, a year ago, you could say open source community, the accuracy is not as good. And today, if you actually just go through there are dozens of models that either have been pre-trained by people or fine-tuned from, say, something like Llama or Mistral, right, where people have taken models and actually have fine-tuned them for very specific tasks or specific languages or specific functions that people care about, that they can show that it's better than GPT-4, right? At a fraction of the size of the model. And so that's just numerically true, right? That for certain things that you want to do, there are already many, many, many open source models that outperform these large monolithic models. Now, the question is, what are all the things that people want? And there's thousands and thousands of them out there. Like, what do I need, and how do I make sure that it's the right one? And that's where somebody like SambaNova is actually helpful. That we can come in and we're purely an enterprise supplier. We focus on enterprise use cases, and so we can come in and allow our clients to leverage our knowledge, our expertise, all of the PhDs that we've hired to actually decide, well, which one of these models do we really think is actually got legs, right? Which of these actually provide the best result? And then we help our customers take those on the platform. We optimize it on the platform, so it's all pre-tuned on it. And so when the platform shows up, all it's got to do is read the private data, and you've got a fine-tuned version of that model for yourself. Right, and so that's kind of the unlocking of it that we've done. Now you don't no longer need to understand what's the difference between Mistral versus Llama 2. You don't need to understand, do I need 8K sequence or 32K sequence? You don't need to understand if this is the right checkpoint. That, does it align to this? Does it align to that? You don't need to figure out, do I need 8 sockets or 16 sockets? Do I need to tune it for this, tune it for that? We take care of all of that, right? That all you need to do is present the PDFs, present the docs, present the data that you have, and the model just fine-tunes, and now you have your own version of a fine-tuned model that understands your business better than anything else in the open domain.
Okay, so we talked about CPUs and GPUs. Tell me about RDUs. What's an RDU, and how is it different from other types of chip that are relevant in this space?
So RDU stands for Reconfigurable Data Flow Unit. Okay, and in the construct of how SambaNova builds this is actually agnostic to anything that your listeners or any developer might care about, right? Because it reads standard PyTorch, right? We can take thousands of models that sit out on Hugging Face, we can download them, and they all run, right? And so the beauty of artificial intelligence and machine learning today is we have abstraction layers in TensorFlow and PyTorch. That is what everyone's building these models around. And then all of the different players can just take those and run them on their platform without having to create these bespoke flows that people have to learn. At SambaNova, we don't do any of that. We take standard models, standard interfaces, plug it in, and just runs, right? And so, so with the reconfigurable data flow, what it is ultimately the architecture that we have inside our platform that allows us to actually get these significant gains. And people ask me, why can't you compact these models that otherwise would run 10 times larger? Why can't you compact all of it into such a small footprint? It's because of the data flow architecture and the way the hardware architecture is actually created. And so if you look at these models, basically it's a data flow in our, machine learning models, they're basically data flow by nature. Right, versus instruction set. Instruction set is you're actually operating around every instruction being perfectly executed in order to actually get one-for-one result. If you're transferring money from ATM, right, you want to make sure that transfer completes correctly, and every single one of those matter, right? And so when you're looking for better weights, right, if you're doing billions and billions of iterations trying to look for a better weight, right, that those you want to be very efficient moving data through and to see if there's a better weight that you can actually anchor your model around. And so the architecture itself has to be efficient in moving a lot of data through, which ultimately data flow is actually a perfect candidate for it. It's just not something that has been commercialized on these architectures that were created 25, 30 years ago, like a GPU or CPU, right? Those have been in place for 20, 25 years, maybe 30 years. And so we fundamentally believe that the AI technology is going to be such a disruptive technology that it's unlikely that no new hardware architecture is necessary in order for us to actually get the maximum efficiency, right? And so that's why we scoured through all the different ways to do this and landed on the best way to do this, because we aren't tied to legacy. We aren't tied to old ways that we got to do this. And so when we started the company 6 years ago, we focused on what's the most efficient way to tackle this new workload, and data flow is the way to do it. Okay, so on a super simple level then, so you can run these open source models, and so RDUs are kind of agnostic as to what model you're running. They'll just work, and they help to improve efficiency, because efficiency has been a big topic of conversation in AI generally, right? People are talking a lot about how much power we're going to be using running these massive large language models across all of these millions of GPUs.
So driving efficiency seems like a big and important question in AI. So what kind of efficiency gains are you creating with these?
Well, the first thing you got to see is that these models are running incredibly inefficient. Most of your audience may be thinking, well, people are training these models. That's a big part of kind of where power goes when it comes to AI. Actually, if you think, and OpenAI is probably is starting to show us this data point, steady state, 80 to 90% of the AI costs will be in inferencing.
Okay, interesting. Really?
Okay,
Wow.
80 to 90% of an enterprise cost in AI will be in supporting these models in production, right?
Okay.
Because these models have to be live. They have, SLA requirements. Customers are engaging with it. You have to keep it, active so that your response time is fast. All of those things, and this is kind of the challenge of running these models in production, that they're not very efficient because these models have to stay live and keep context of what you're talking to the user about. And yet you and I, right? You and I, we don't type that fast. we can only type this fast. And then when we get the response, we're reading it. Then while we're reading, we might be interrupted by somebody talking to us, right? And the entire time that you're talking to a friend and chatting about something, or checking the oven or whatever you're doing, that connection on the server side has to stay alive waiting for you.
Wow.
Right? And so that's the construct what we do today. I mean, it's mind-blowing, but people say, well, why are we short of chips? And why do we have so much power in the explosion? Why is the cost going through the roof? And why are we using it so inefficiently? Because that's the construct that you have no other choice. That's kind of what the world we live in today, that the world is incredibly inefficient. We're driving the needs for chips through the roof. We're driving the cost of chips through the roof. We're driving the power because we don't have the right construct, right? And so
interesting. So it's like is this a good analogy when you leave your computer monitor on and there's a screensaver just running, and it's just using power just to exist when you're not even using it? That's basically what we're doing with these insanely complicated large language models. They're just staying there waiting for you to come back the whole time.
Yeah, well, it's worse than that, because that screensaver, let's just say that screensaver takes 3 minutes to reactivate, right? So you don't even want to turn on the screensaver. So you actually have the screen on at full blast the whole time waiting, right? Because to activate and deactivate takes many, many minutes. And we don't have that level of patience. And so we think we're going to be away for only 30 seconds. And so we don't want to activate the screensaver. And we stay. Well, it turns out then we left for, say, 45 minutes, right? And so the screen is not in screensaver mode at all. It's actually fully active because it takes so long for you to actually switch out and come back on.
Right. So really, it's the human attention span is part of the problem here. If we weren't so impatient, then maybe we might be able to be a bit more efficient with our GPUs. Is that what you're saying?
Well, no, I think it's actually a solved problem. We solve it in a different way, and that's why we can collapse the footprint by 10x, because we're
10x.
10. We can collapse the footprint by 10x because it's something that the world already has seen in the non-AI computing world. It's called multi-tenancy, right? Okay. It's being able to serve many different users in a secure and private way so that the same hardware is able to actually serve and have that otherwise a very long switching time to be minuscule and not noticeable. And so, I mean, you see that today. If you actually run traditional workloads in a multi-tenant way, if you think about kind of how people go on the cloud and they're not all hogging individual pieces of hardware by themselves for a long period of time, right? They're all dynamically being managed. It's just that the current existing infrastructure does not allow us to do that. And so we're in this world of actually having to have everybody in this window for a dedicated amount of time.
Wow. Well, interesting. So are you the only people doing that then? Multi-tenancy?
As far as I know, but again, I think proof is in the pudding. I mean, we've got deployments where people can see these major collapsing of the cost and of the infrastructure and the power, because we're able to host hundreds of models on a single platform, where otherwise every model requires a separate GPU. right? And so, so
Right.
you're
Okay, I get you. So that the fact that it's agnostic to different models really helps that multi-tenancy proposition, because it doesn't matter. You don't
perfect,
have to have a specific GPU for a specific model.
perfect, perfect. That's
Okay.
exactly that's
Okay.
exactly
Okay. Wow.
perfect.
Yeah. That's great. Yeah. Okay. I can see why you guys have been able to raise so much money. It's a really compelling proposition, I think. That
And
sounds
it's
really
hard to
interesting.
do. It's hard to do.
Yeah,
And
I
people are,
bet. I bet.
why are you tackling the complexity of building chips? Because there's no other way to do it, right?
Right.
If
Yeah.
your hardware does not support this capability, you will forever be in a single tenant mode. Every model requires a separate chip, and those chips are really expensive, right? And
Yeah.
so you have to tackle what ultimately is a problem that everybody has, which is you got a lot of models coming, a lot of users using it. It's only going to explode more to the extent that you think that a lot of users already using AI. We're two orders of magnitude away from what everybody, getting everybody on it, right? And you have to find a more efficient way. And that more efficient way isn't by reducing power by 10%. That's not the
Mm.
more efficient way. The more efficient way is just cracking this whole thing open and let hundreds of models be shared on a single platform so that people can use it. Why do I know that that's what it is? Because that's what the industry has already proven over the last many decades, that level
Yeah.
of efficiency works, right?
Yeah.
How do we
Yeah.
power
Yeah.
the clouds today? We use multi-tenancy and virtualization to actually allow us to actually get the economies of scale. And that's where we don't have an AI today. And that's what SambaNova is bringing.
Right. Yeah. Because that was what AWS did, right? That was their fundamental
For
innovation.
traditional CPUs, right? For traditional
Right.
CPUs is about multi-core. If you think about kind of what we did in the 90s, we went from single core chips to multi-core. But having just multi-core wasn't enough. You had to have a software layer above it to do virtualization, right? And that's companies like VMware showed up and were able to create a virtualization model that allows the users to get the look and feel of a dedicated environment when the underneath is being shared, right?
Mm.
And that's
Mm.
ultimately what you need in this, that you need every model to look like they have their own dedicated hardware, but you can't actually give them the dedicated hardware because you run into this problem. So you need to have this way of virtualizing this so that you can host hundreds of models with the latency and performance that individual models have,
Mm.
but without having this explosion in power, explosion in cost, and the availability problems, and all the things that you're seeing we're experiencing today, is just because we don't have the architecture in place.
Interesting. Extremely interesting. I had no idea about any of this, so I'm really glad I had you on. This is great. So I'm conscious of your time, and we are running close up against it. The last thing I wanted to talk to you about is the chip manufacturing supply chain. So we could probably spend ages on this. We don't have to be here all day on it, but I just want to know, particularly TSMC and the supply chain of chip manufacturing generally has been in the news a lot. People talk a lot about, the geostrategic importance of Taiwan and the idea that maybe the US is going to start building out more manufacturing. Why is it so difficult? Why is it so hard to build these things that there are only a few companies at every part of the supply chain that are even able to execute on this manufacturing process at all?
Well, this goes a little into the weeds of chip design, and I've been doing chip design for 3 decades now, and so
Yeah.
seeing how the technology evolved. But two things I want to actually impart on your audience so they can start thinking about. But as you may know, when we do chip design, we're laying down transistors. We laying down tracks, right? Think of them as little rectangles that we lay down, like Lego blocks that you might build, very, very sophisticated Lego blocks, right? But imagine these structures that we're etching into the semiconductor. Okay, we're etching using lasers to actually etch the design into these wafers, these semiconductor wafers. Except the dimension of each of the design is smaller than the wavelength of light.
Wow,
Okay,
really?
let's take a minute and just think about the fact that you're etching these design. It's a paintbrush. You're doing fine writing with paintbrush, except the brush is 4 to 6 times, 8 times wider than the design that you're trying to paint.
Wow.
Right?
So you're doing it with lasers, but it's smaller than the wavelength of light. Surely a laser is light.
Well, that's what I
Right?
mean. Your laser is
Yeah.
light, right? Laser. So the laser has a wavelength that is much wider than the actual dimension you're trying to print.
Wow. God, this is
Okay, so
alchemy.
now you're
So
entering.
how do you how is that possible?
Exactly. So this is where a handful of people in this world really understand the science of how to do this. And look, I can only say I've got cursory understanding, and since I'm the user of that technology. I'm not the builder of these factories, right? And so I'm a user of it. But the complexity of what you're doing, right, is so high because every layer that you're dropping down is narrower than the tools that you'll have available for you to actually drop down, right? The
Wow.
tool means the laser. Okay, that's the one. Now, the second thing is chips today, like chips that are powering these industries, 100 billion transistors, 100 billion. Okay, and so think of them as components or individual items that you have to put together in constructing a house. I would argue that if you take an average 5-bedroom house that you construct from the beginning, there are not a billion. There's not a billion components you have to orchestrate, install, screw. If you think about a house, when you're building a house, it's thousands of components.
Yeah.
But nowhere close to a million. Nowhere close to a million. Count every screw, every nail, right? Count every faucet, there's not a million. There are not a million individual items that all have to be orchestrated together, right? And so you start thinking, okay, well, so let's just call it, 100,000 individual things. Okay, so then I've got to build 10 of those houses to get to 1 million. That's 1 million.
Yeah.
I'm still a way off from 100 billion.
Yeah, still I can't even.
Right,
do
so
that.
you think about, okay,
You probably can.
maybe if I think about a skyscraper in New York, maybe a skyscraper. Okay, well, in skyscraper in New York, you can imagine, okay, maybe there's 1 million components there, maybe 5 million components in that. Okay, well, I'm still nowhere close to 100 billion. So I got to build an entire city, right, with skyscrapers, And so then you kind of think about the complexity of what all has to happen, which amazingly they do. And then you have this kind of long lead time because, when you put 100 billion of anything together, right?
Yeah.
When the source of the light is, wider than the thing that you're trying to print, right? And then it's not perfectly accurate. So then you have the yield issues that people talk about, right? How well does it yield? Because it's a statistical thing, right? And so the complexity of what we're trying to do, even though in the end it shows up as this tiny little piece of glass, right? That this tiny little piece of glass that you can hold up in your hand and it looks like a chip, and it's like, oh, does all this? Well, there's a lot of stuff packed in there. It's just hard for us to conceptualize, right? That 100 billion things have to all work together. Any one thing is off, the whole thing's broken.
Yeah, wow. So they're building an entire city with a tool that's bigger than the actual things that they're constructing.
Yeah,
sounds pretty wild. Well, that's a great.
I wake up and I'm amazed that the whole thing works at all, right?
I bet.
But this is kind of where we are. I mean, this is some amazing people that have been doing this for a long, long time, building foundry, building technologies, and driving us into these, new technology nodes. I mean, that's kind of what that is. That is such a differentiated technology that's just hard to replicate, and there are only so many people in the world that are able to make that work.
Yeah. And so you work with TSMC, is that right?
Yeah. Our chips are all built out of TSMC.
Yeah. And how do you enjoy interacting with them? Do they all strike you as like just super amazingly smart people? I would imagine so.
They're fantastic. I mean, SambaNova uses them, but I've I built that partnership with TSMC goes way beyond this company. I've partnered with them for years and years before I started this company, and so that relationship has been really strong. And they're just amazing folks. They really know what they're doing.
Yeah. Well, it's great talking to experts. I love talking to experts. That's why I do this, is because it's always interesting to talk to somebody who knows a lot more than you do about something that you're interested in. So I bet the folks at TSMC are, blows my mind. So look, I'm conscious of your time. You've been very generous with it. To wrap up, is there anything that I haven't covered that you think people should know about what you're doing, what your latest products, or anything that's super exciting that you have coming up that you'd like to tell people about?
Yeah, I mean, SambaNova, we are full stack, and this is where you hear, Sam Altman at OpenAI and other people talking about full stack, meaning I want to build chips to models, and so you see the world already gravitating towards the need to actually build much more efficient systems while delivering these very sophisticated models. And this is what SambaNova has, and so we're excited. We focus only on the enterprise. We deliver these models for private deployment, so you can train in private, deploy in private. Your data is your most valuable asset, and what we do is we enable our clients, our companies that are our clients, to be able to do all in private, so you don't have to disclose your data into an environment that you're uncomfortable with. And that's kind of been something that we've been quite successful in. We're in 15 countries these days, and we're super excited about the type of use cases that our customers tackle. And so to the extent that, the world continues in this trajectory where models are getting bigger and bigger, they're getting more and more complex. Like you said, hiring that talent to do it by yourself is really, really hard, right? And the efficiency, the infrastructure that you have to deploy continues to get too expensive. We become a really, really good option for companies that want to get a quick head start and not have to do all this work and deploy really, really efficiently. And so excited to continue the conversation with your audience and with other folks that that there are continuing to advance the trajectory we're already on, and it's going to continue to excel over the next 12 to 18 months.
Awesome. Well, look, Rodrgo, it's been really extremely interesting having you on. You're incredibly knowledgeable, and I've really enjoyed talking to you. So thanks very much for joining me.
Of course. Thanks for having me.